The lesson topic for this video is trig, sine, cosine, and tangent, and solving right triangles. Actually, most of this is a review from geometry. Hopefully, you'll recognize the sine, cosine, and tangent functions that we are talking about in this lesson. So, the first thing you need to remember is that sine, cosine, and tangent are used when you have a right triangle. The sine, cosine, and tangent ratios are a ratio or fraction that compares two different side lengths of a right triangle. The sine, S-I-N, is the abbreviation for sine. It's actually spelled S-I-N-E. The sine ratio is the opposite side over the hypotenuse. Now let's remember what we mean by opposite side and the hypotenuse. First of all, the easiest one to remember probably is that the hypotenuse is always across, the side that is across from the right angle. So this is the hypotenuse. We abbreviate the hypotenuse with HYP. Now what do I mean by opposite, the opposite side? Well, the opposite side depends on what angle you're using as your reference. Let's say that in this problem, we're talking about this angle down here. Okay, let's call this point A right here. Let's call this point B, and let's call this point C. Well, that means the opposite side is opposite of this angle right here. I taught last year in geometry, if you had me as a teacher, I always taught that if you were standing in this corner where point A is, if you were standing in a triangular shaped gym, and your coach said, or the teacher said, run to the opposite side of the room, you would run over here. Okay? You wouldn't run here. That's not the opposite side. You wouldn't run here. You would run over here. So that is the opposite side based on angle A. So that's the opposite side. Again, if I were talking about angle C as my point of reference, the opposite side would be over here. All right, so if I was going to write the sine ratio for angle A, I would write the opposite side over the hypotenuse. This side here over this side here. The cosine ratio is similar because it still has the hypotenuse in the denominator, but the cosine has the adjacent side in the numerator. Now if you look at the picture again, if we already know that this is the opposite side from angle A and this is the hypotenuse, that means this side here must be the adjacent by process of elimination. It's the only one left. Adjacent also means next to, and if angle A is right here, then the two sides that are next to angle A or connected to it are these two. Well, we already know this is the hypotenuse, so that's another reason we would call this the adjacent side. So the cosine of angle A would be this adjacent side over the hypotenuse. Lastly, we have tangent. Tangent is the opposite side divided by the adjacent side. Opposite over adjacent. So again, based on angle A, right here, the opposite would be this side over the adjacent side, which is this. Notice in tangent, we do not use the hypotenuse. Now, you may remember there's a little mnemonic device that people use to help us remember the trig ratios. And that is SOHCAHTOA. All right, SOHCAHTOA. And the reason we use this to remember, we use S as the sine ratio, C is the cosine ratio, and T is the tangent ratio. And the O's stand for opposite, and the H's stand for hypotenuse, and the A's stand for adjacent. So this reminds us that the sine ratio is the O and the H, the opposite, over the hypotenuse. It's always the opposite over the hypotenuse. So the first letter on top, the second letter on the bottom. The cosine ratio, remember then, is the adjacent side on top in the numerator and the hypotenuse in the denominator. And lastly, the tangent ratio. Tangent is opposite over adjacent, the opposite side over the adjacent. SOHCAHTOA. Okay, so you hopefully, like I mentioned earlier, are familiar with this, that you remember it and you've seen it before. So let's take a look at this first example of how to use sine, cosine, or tangent to help us find the value of a missing side. Right now we're trying to find the value of y, and y is the length of this side of the right triangle. In order to find it, the first thing I would do is always keep in mind, first of all, to think about what angle we're using as our reference point. It's the angle that we know the measure of. So that's the 45-degree angle. Now, based on that angle, I like to go through and label my sides. I typically will start with the hypotenuse. Since this is my right angle right here, the hypotenuse is the side that's across from it. So this is the hypotenuse. Based on this angle right here, if I were standing in this corner of a triangular-shaped gym and I ran to the opposite side, I would run over here. That means this is the opposite side. And again, by process of elimination, this must be the adjacent side then. All right. So then next what we're going to do is we're going to determine which trig ratio to use to solve for y. Well, obviously, if I need to solve for y, I need my trig ratio to include the hypotenuse. What other side am I going to use depends on what data I'm given. I'm given that this side over here is 13. This side that's 13 is the adjacent side. So since what I'm trying to find is right here, y, and what I know already is right here, 13, I'm using these two letters, a and h. So which trig ratio has an a and an h in it? This is where you might write SOHCAHTOA on your paper somewhere. This is another way that some people write it. So which of these trig ratios has an a and an h in it? This is the only one. So we know we're going to be using cosine. So I will write cosine, and then next to cosine I write the angle measure that I am given, 45, and then I say that that cosine is that ratio between the adjacent side and the hypotenuse. The adjacent side always goes on in the numerator because it's the first one listed in our ratio. It's always in the numerator. So a is 13, so I'm going to write 13 in the numerator. And the hypotenuse goes in the bottom, and the hypotenuse is y. Now we need to solve this for y, and the way I typically teach this, there is more than one way, but I usually teach this by saying let's turn both sides of the equal sign into a fraction. And that way we can use cross multiplication, because we have an equal sign in between two fractions, we can cross multiply to solve. So we multiply it this way, 13 times 1, and 13 times 1 is 13. And we cross multiply this way, and we get cosine of y, cosine of 45 times y. To solve for y, notice that cosine of 45, which by the way is just a number, this is being multiplied by y. So in order to get y alone, we need to divide by that value. So I'm going to divide by the cosine of 45 on this side of the fraction so that they cancel out, which means I need to divide this side of the fraction by cosine of 45 as well. So we get y equals 18, whoops, let's get rid of that, 18.385. What I highly suggest at this point is that you grab your graphing calculator and compute 13 divided by cosine of 45 to see if your calculator is in the right mode. Most calculators start in default mode of radians, and we need to use degrees for these problems. If you compute 13 over cosine of 45 and do not get 18.385, please make sure to talk to me during class about changing the mode of your calculator if you don't know how. All right. Let's try this second one. The question asks us to find the measure of segment RT. If you remember that notation from geometry, find the measure of segment RT. So I'm going to go ahead and find RT and put an X there. That's what we're trying to find. Once again, I'm going to label my sides based on the angle that I am given. I'm given this 24-degree angle right here. Based on that angle, as always, here's my right angle. So across from the right angle is my hypotenuse. And then opposite of this 24-degree angle is this side over here, opposite. And that remains, or that leaves the adjacent, that side there. Okay, so once again, which trig ratio are we going to use? Well, I'm trying to find x, and that's a opposite side. And I know that this side is 33, and that's the adjacent side. So I need to know which trig ratio uses the opposite side and the adjacent side and leaves out the hypotenuse. Well, that would be tangent. So we're going to write tangent of the 24-degree angle is equal to the ratio of the opposite side over the adjacent side. Again, opposite has to go on top and adjacent on the bottom. So that's x over 33. Again, I'm going to change this into a fraction by putting that over 1, and I'm going to cross multiply. X times 1 is x. And if I multiply it this way, tangent of 24 times 33, again, that's a time sign there. Now this is another place that your calculator may run into issues. Some calculators, you need to close the parentheses off around 24 before multiplying by 33. The correct answer should be 14.693. If you did not end up with that value for the length of segment RT, again, we should talk about calculator issues you may be having in class. Very quickly, I want to run through how to draw a right triangle when doing a trig problem. Typically, and not always, but typically we're going to have triangle ABC. So our vertices, just like in geometry, are going to be A, B, and C. And usually I will write which angle we are going to use for our right angle, or it will be shown somehow. So let C be the right angle. Well, obviously it doesn't matter what the shape of the right triangle looks like. Just make sure you have a right angle if you were asked to draw one of these. I could draw a long, skinny right triangle, but it's just not as typically used. So we'll just go ahead and use this more typical triangle. Our vertex C, capital C, is going to be right here because it's the right angle, and that's what it says right here. If the other two vertices are A and B, it doesn't matter if you're drawing your own triangle where you put A and where you put B, unless it specifies. And then after this, there's just one other very common thing that we do when labeling triangles. And that is we use a lowercase letter for each of these vertices to be the side that is opposite that vertex. Okay, I'll say that again while walking through it. If this vertex is C right here, capital C, it means that the side that is opposite it will be lowercase c. Now it's hard to see that that's a lowercase c compared to this one, but you'll see it better with A and B. Vertex B is right here, which means we will label the side that's opposite angle B with lowercase b. And then similarly, we're going to go from across vertex A, and we will label the side opposite that with a lowercase a. So when you set up your triangles, that is what you will need to do.